morning. Good morning, Sujit. Good morning, Aniket. Good morning, Rupesh. Good morning, Sahil. Good morning, Kalpesh. Good morning, Gauri. Chala, join fast. We are going to wait for 1 or 2 minutes. Good morning, Karthik. Okay. Now we are going to start our chapter 1. In our last lecture, we just revised the basic concept required for that chapter 1. That is, the name of the chapter is Sources of Electrical Power and Network Theorems. Okay. Before that, happy Navratri to all of you. Okay. Thank you. Thank you. Thank you, Aniket. Okay. In our last lecture, we discussed some basic definitions about electric current, electric potential, resistance, and their units definition. Okay. Now here, in our last lecture, we start with the laws related to resistances. Whenever in any circuit, resistances are in series and resistances are in parallel. So what is the effective resistance Or how you find out the potential drop across that each resistance, that we are going to study now. So in our last lecture we studied that whenever resistances are connected in series, suppose R1, R2 are connected in series, then overall effective resistance between the two ends of that series combination, that R1 and R2 are in series, therefore between terminals, suppose A and B, here your R1 and here your R2, means these two are in series. So what is the overall resistance between point A and B? RAB is the effective resistance between A and B. So RAB is equal to R1 plus R2, or RS is equal to overall effective series resistance is given by R1 plus R2. Exactly opposite, if that resistances are in parallel, you understand, parallel one after other, and ends are get connected between 2 points. Between these 2 points, resistance R1, resistance R2, means these two ends of both the resistances are connected together. At that time, what we say, that R1 and R2 are in parallel. So between that A and B points, R1 and R2 are in parallel. So effective resistance of the parallel combination is given by RP12. R1 and R2 are there. Therefore, we may say that RP12, P for parallel combination, 1 and 2 says that resistance 1 and resistance 2 are in parallel. That's why RP12 is equal to, or 1 up, RP12 is equal to R1 into R2 upon R1 plus R2. Or what is the basic formula? The reciprocal of effective resistance of parallel combination is equal to the addition of their reciprocals. That is the law in word. Don't frightened about the definition. You just remember that 1 upon RP12 is equal to 1 upon R1 plus 1 upon R2. By cross multiplication, we get RP12 is equal to R1 into R2 upon R1 plus R2. That is the standard formula to calculate the equivalent resistance between two terminals. Between two terminals where the two resistances are connected in parallel. Okay. So after that, the next formula is potential division. Now concentrate all of you. This is very important formula. Everywhere you require that. Means whenever 2 or 3, we consider the example of 3 resistances. Write down simultaneously, or I am going to give you some time to draw the diagram and write all description. Wait. So here suppose 3 resistances. Here your R1, here your R2, and here your R3. So here R1, R2 and R3, these 3 resistances are connected across a battery of certain potential. Suppose that battery having potential V. So due to that battery there is a current I. Conventional direction is from positive to negative and complete circuit is present there. So here V is the potential drop applied across the series combination of R1, R2 and R3. Okay, and I is the current. Now whenever the resistances are in series, the current through them is same. You know that already, you know that this thing. That I is the current through R1, I is the current through R2 and I is the current through R3. Therefore, how you write potential drop? You know V is equal to IR. Therefore, you say that V1 is potential drop across R1, V2 is potential drop across R3, R2 and V3 is the potential drop across R3. So V1, how you write? How you describe the diagram? R1, R2 and R3 are in series. R1, R2 and R3 are in series. How you describe this diagram? These three resistances are connected in series. I is the current through R1, R2 and R3. The same magnitude of current flows through R1, R2 and R3. But V1 is potential drop. Potential drop, in short I write PD. V1 is potential drop across R1. V2 is potential drop across R2 and V3 is potential drop across R3. Means whenever the resistances are in series, at that time the current through them is same but potential drop across them is different. And what you say, overall V is the potential applied across that series combination, therefore V is equal to V1 plus V2 plus V3, right? V is equal to V1 plus V2 plus V3. Now how implies that V1 is the potential drop across R1, which says that V1 is equal to I into R1. What do you say about V2? Potential drop across R2 is given by I into R2. What is the potential drop across R3? V3 equal to I into R3. Okay? So V1 is the potential drop across R1, V2 is potential drop across R2, V3 is potential drop across R3. And what is the value of V1? V1 is equal to, according to the formula of Ohm's law, V is equal to IR. So V1 is potential drop across R1, therefore the current through that R1 is I, therefore V1 is equal to I into R1, V2 is equal to I into R2 and V3 is equal to I into R3. Okay, and overall potential, suppose 3 volt battery is applied across that series combination, then overall potential drop must be the addition of that V, therefore 3 volt distributed in V1, V2 and V3. V1 plus V2 plus V3 must be equal to 3 volt whenever 3 volt battery is connected across that series combination. Okay, so up to this, all these things you already know. हे काही नवीन नाही आहे, हे सगळं तुम्हाला येत आहे. Okay, then what we want to study? We want to find out the value of individual V1, V2 and V3. So potential divider for listen all of you. I am going to try on our normal Wi-Fi, normal internet. I think there is a power failure. Please. दिसतंय आता clear? Okay? Okay, Kalpesh. Now please join all of you. Send a okay? All of you, are you there? Because we are going to study very important topic, that is potential division. Okay. जरी डिस्कनेक्ट झालं तर ज्या माझ्या माहितीप्रमाणे 1-2 मिनिटांमध्ये परत आपण कनेक्ट होतो. सो स्टे लाईव्ह. ओके, बिटवीन 1 minute अगेन इट इज कनेक्टिंग. टुडे देअर इज अ इंटरप्शन ड्यू टू दॅट पॉवर प्रॉब्लेम. ओके, So potential division, whenever for this diagram, now we want to find out V1. What is the potential division formula? Says V1 equal to R1 upon R1 plus R2 plus R3 multiply by V. This is the standard formula to find out the potential across resistance R1. Now when we want to find out the potential across R2, that's R2 plus R3. And now when we want to find out V3 potential across resistance R3, at that time what you say? R3 upon R1 plus R2 plus R3 into V. This is the standard formula. Potential division means here overall potential applied across that series combination is V. And you know already know that overall RS is equal to R1 plus R2 plus R3. Now you know overall V is equal to overall current is I and overall resistance of the combination is RS, where RS is equal to R1 plus R2 plus R3. Therefore V is equal to I into RS. V is equal to, you have to remember V1, and you are given the values of R1, R2, R3 and V is given. At that time you are able to calculate the potential drop, how that potential V is divided across these three resistances. Means the value of V1 is given by R1 upon R1 plus R2 plus R3 into V. The value of V2. V2 is the potential drop across that R2. What is the, how much potential will drop across resistance R2? The formula for that is R2 upon R1 plus R2 plus R3 into V. And how you calculate the potential drop across V3 R3? That is V3 equal to R3 upon R1 plus R2 plus R3 into V. These are the potential division formulas. Write down all these things. These are very important. Writing proper, write down all current flow through all three resistances. Okay? So V1 is potential drop across R1, V2 is potential drop across R2, V3 is potential drop across R3. And you know V1 is equal to I R1. You think that you already know the formula for V1, that is equal to I into R1. But if you don't know about the current through the circuit, if you don't know what is the magnitude of current due to V, at that time you have to calculate that V1 by using this. Write down all these things. Now we try to simplify one numerical. Simple thing. Only write down all these things. I am going to simplify one numerical related to that. And how these formulas are there. From this we try to simplify. Okay? Do you complete all the writing? Okay, Kalpesh. Now is it clear? Okay, Kartik. Now these are the potential division formulas. How these formulas are there? From this one only. Now you know that series resistance is R1 plus R2 plus R3. Therefore, if we insert the value of all this in place of R, failure. Normal net not possible. सारखं ते discuss lecture. Okay? we will continue in our next lecture, because this one is very important. It is the potential division. Throughout the syllabus there